Hello everyone. Now we are discussing chapter 5, continuity and differentiability. In the previous class, we discussed about the concept continuity and we solved some examples on continuity. 3 examples are over in the last session. Now we will start this session with example number 4. The question is like this. Show that the function f given by f of x is equal to its value is x cube plus 3 if x is not equal to 0 and its value is 1 if x is equal to 0. We have to show that it is not continuous at x is equal to 0. First, what we have to check whether the given function is defined for all the real numbers or not. Particularly at x is equal to 0, it is defined or not, that we have to check first. Yes, at x equal to 0, the function is defined. At x equal to 0, the value of the function is 1. For x is equal to 0, the function is defined. Therefore, first we will write that the function is defined at x is equal to 0. Okay. Next, what we have to find? We have to find functional value at x is equal to 0. At x is equal to 0, what is the functional value? What is f of x value? Its value is 1. If you substitute in place of x as a 0, then also the value of the function is what? 1 only. Because at x is equal to 0, the f of x value is 1. Now, we have to find limit of this function at x tends to 0. X tends to 0 from the left side and from the right side. That is less than 0 for greater than 0. X is not equal to 0 means what? This implies either x is less than 0 or x is greater than 0. Nothing but for left hand side of the 0 and for right hand side of the 0, the functional value is same. That is polynomial function. X cube plus 3 is a polynomial function. So, no need to find LHL and RHL for this function. Both are same because for left hand side and right hand side, the value of the function is same. Combinedly, we can find the limit of f of x as x tends to 0 is equal to limit of what is f of x value as x tends to 0. The functional value is f of x is equal to x cube plus 3. We have to substitute in place of f of x as x cube plus 3 as x tends to 0. The function is polynomial function, so we can substitute in place of x as 0 only. If we substitute in place of x as a 0, 0 cube becomes 0, 0 plus 3 is 3. Therefore, the functional value at x tends to 0, or we can say as x converges to 0, the functional value is 3. But at x is equal to 0, the functional value is 1. Therefore, limit of f of x as x tends to 0 is not equal to f of 0 because its value is 3 and its value is 1. They are not equal. If you draw the graph of this function, you will get the graph of this function like this. We'll find for x is equal to 0, they are given it as a 1. For x is equal to 0, the y value is 1. So, we'll mark here. And for minus 1 is nothing but less than 0. For less than 0, the functional value is x cube plus 3. If you substitute in place of x as a minus 1 cube is minus 1 plus 3 is plus 2. Therefore, for minus 1, the value is plus 2. We'll mark here. Okay. And for positive 1, plus 1 is greater than 0. Again, the functional value is x cube plus 3. So, we have to substitute in place of x as a 1. 1 cube is 1. 1 plus 3 is 4. For 1, what you will get? 4 will get. Okay. And we'll check for nearest point of 0. That is for 0.1. For 0.1, if you substitute for 0.1, 0.1 cube is what? 0.001 will get. Okay, 0.001 plus 3, 3.001 will get, that is here. Again for minus 0.1, what will get? If you substitute in place of a x as a minus 0.1, minus 1.1 cube is minus 0.001. Therefore, the value becomes what? 2.99. That is here 2.99. Okay, very nearest to 3 only. 2.99 means. Okay, for minus 2, what is the value? Minus 2 cube, that is minus 8. Minus 8 plus 3, minus 5. So for minus 2, minus 5 will come. Next, for plus 2, 2 cube is 8, 8 plus 3 is 11. For 2, you will get 11 somewhere here. If you join the points of this graph, you will get the graph of this function like this. And here it will continues. Okay, but at x is equal to 0, the value of the function is 1. It is not equal to 3. Therefore, we have to make a hollow hole here. Nothing but, if you want to draw the graph of this function from here, we have to lift the hand at x is equal to 0, because we have to mark at y is equal to 1. Again, for positive values of x values, again we have to move like this. Therefore, we have to lift the hand at x is equal to 0 to complete the graph. Therefore, the function is not continuous at x is equal to 0, because at x is equal to 0 we are lifting the hand. Understood? Therefore, the given function is not continuous at x is equal to 0. This is by the graph. And we are getting here limit of f of x is, as x tends to 0 is not equal to f of 0. Therefore, the function is not continuous. Therefore, the function is not continuous at x is equal to 0. Understood? Let's consider example number 5. That is, check the points where the constant function f of x is equal to k is continuous. That is, we have to check that the constant function is continuous at every point of its domain or not. Okay? Yes. The constant function is defined from where to where? F is from R to R, and it is defined as f of x is equal to k. It is defined for all the real numbers. Why? If you tell any real number, the value of the function is k only. It is defined for all real numbers. Therefore, we'll write that first. The function is defined for all the real numbers. For x is equal to 1, the function value is k. For x is equal to 2, the function value is k. For 10,000, the f of x value is k. For minus 5, the f of x value is k. For any real number, the function value is k only, and it is defined. Therefore, the function is defined for all the real numbers. Now, we will check whether this function is continuous or not. For that, we have to consider one point in the real number system, that is, let C belongs to R. Let C be the any real number. At this point, we have to check the function is continuous or not. Okay. First, we'll find functional value at x is equal to C. At x is equal to C, what happened for f of x is equal to k? We have to substitute in place of x as a C. F of C always equal to k only, because no x terms are there to substitute C value in place of x. Here k is there, we have to keep as it is. Therefore, f of c becomes k. Therefore, functional value at x is equal to c is k. Next, we have to find limit of function as x tends to c. Limit of function as x tends to c is equal to limit of f of x. What is the value of f of x? K. Its value is k as x tends to c. X tends to c means for left side of a c as well as for right side of a c, the value of the function becomes what? K itself, because there is no x value here to substitute in place of x as a c. So we have to write k itself. limit of f of x as x tends to c is equal to k, as well as the functional value at x is equal to c is also k. Therefore, we can conclude that limit of f of x as x tends to c is equal to f of c, because both have a same value, that is k. Therefore, limit of f of x as x tends to c is equal to f of c. By definition of continuity, we conclude that therefore the constant function f of x is equal to k is continuous for any number, any real number c. Therefore, the function is continuous at every real number, because c is a in general real number. Therefore, we can conclude that the constant function is continuous at every point of real number. So, in this session, we discussed 2 examples. In the next session, we will continue the concept of continuity only. Till then, thank you.